Kia ora again, everybody. This video looks at how you might go about presenting your work, and I've used an example of another polygon that you might try out. So my one was a kite shape in this video. So the first picture that I put into my work is the picture of the shape with the circles stacked inside it, or packed inside it. So that one there is just to prove that I could fit my 6 circles inside my shape. The second picture looks at how I calculated the area of the shape. So this is my proof to show the area is what I say it is. To calculate the area of unusual shapes like kites, pentagons, hexagons, all those kinds of shapes, the one way of doing it is by using triangles and then calculating the area of the triangles and then using those areas to calculate the entire shape. So if you look at my kite, I've divided my kite into a smaller circle, a smaller triangle at the top here, and a larger triangle underneath. And then I went on and I calculated the area of each triangle. So to calculate the area of a triangle, we take the length of the base of the triangle. So in this case, along here, it's 60 millimeters. And then we take the height of the triangle from the high point down to the base. And in this case, it was 40 millimeters. And we multiply those totals together. So 60 times 40, that gave me 2,400. And then there's one more step, and that's to divide that by 2. So half of 2,400, or 2,400 divided by 2, that gives me 1,200. So the area of that top triangle is 1,200 millimeters. To calculate the other triangle, once again, the base here, that's 60 millimeters as we established, and then the height from the highest point down to the base is 85 millimeters. So I've got to calculate 85 times 60. So you can see I did a few steps to do that. 80 times 60, 5 times 60, and that gave me 7,800. And then I've got to divide that by 2. So 7,800 divided by 2 equals 3,900. You can see there's a mistake there in my calculations that I'll have to go back and fix up. So the area of the entire kite is the area of the top triangle and the area of the bottom triangle added together. So that's 5,100 millimeters. So I want you to do the same when you calculate your work. Show some proof that you can fit your circles inside your shape, and then have some proof to show what the area of your shape is. And remember, we're aiming to get the area, the shape that takes up the smallest area. So once you've worked on a few shapes, you'll be able to start comparing them and deciding which ones are optimal. Thank you, and we're looking forward to seeing your work.